Two helicopters sit in a museum in Alabama. They will never fly a combat mission. They will never fire a missile in anger. They exist only as monuments, polished, complete, and utterly finished, to a machine the United States Army spent 21 years and $6.9 billion building, and then killed before it ever saw a single battlefield. This was not a failure of engineering. The radar cross-section worked. The rotor worked. The stealth geometry worked exactly as the physics said it would. Every technical promise made in 1991 was, by 2004, a promise kept. And still, on a February morning in Washington, two generals stood behind a podium and ended it anyway. The story of the RAH-66 Comanche is not a story about a helicopter that failed. It is a story about a helicopter that succeeded and arrived in a world that no longer had any use for what it was built to do. A world that had, sometime between the drawing board and the assembly line, quietly stopped needing what it once could not live without. Somewhere between the Cold War that justified it and the war that killed it, the ground shifted under the entire program. The machine never moved. Everything around it did. It was 1982. Every attack and reconnaissance helicopter flying in the United States Army was built on the same accepted premise. It would be seen. A helicopter in low-level flight over Central Europe would show up on radar as a bright, unmistakable return. Its rotor disc alone, reflecting energy back to the ground like a mirror tilted skyward. Its engines ran hot enough to paint a clean signature on any infrared seeker within range. Its hover created a rotor wash signature audible from more than a mile away, long before the aircraft itself came into view. None of this was considered a flaw. It was simply what a helicopter was. Soviet doctrine had built an answer to this signature, layer upon layer, for 2 decades. Man-portable SA-7s. Radar-guided ZSU-23-4 anti-aircraft guns, 4 barrels spitting 3,000 rounds a minute into any low-flying aircraft that entered their envelope. Mobile SA-9 batteries mounted on armored vehicles, moving with the very tank columns a scout helicopter would be sent to find. NATO war games through the late 1970s returned the same grim arithmetic each time. In a full-scale engagement on the Central Front, American scout and attack helicopters were expected to take catastrophic losses within the first days of contact, not because the pilots flew poorly, but because the machines themselves had nowhere to hide. This was the accepted law of low-altitude combat aviation. Survivability was a function of speed, of terrain-hugging skill, of luck, not of invisibility. No helicopter had ever been built to disappear. One requirement, drafted quietly inside the Army's aviation branch that same year, refused to accept that as permanent. It did not propose flying faster. It did not propose flying lower. It proposed building a helicopter the enemy's radar could barely see at all, and if the wars of the next century ever reached that battlefield, the machine born from that requirement was meant to survive it. It would take 21 years, $6.9 billion, and the work of 2 of America's largest aerospace contractors to find out whether that idea could actually fly. And it would take 1 afternoon in February to decide it no longer mattered. The requirement had a name before it had a shape. LHX, the Light Helicopter Experimental. It began not as a single aircraft design but as an Army study, launched in 1982, tasked with answering a question that had been quietly building for a decade. The service was flying too many different helicopters, built by too many different companies, doing jobs none of them had been designed to do together. By the early 1980s, Army Aviation was fielding the OH-58 Kiowa for scouting, a light, unarmored aircraft designed in the 1960s that carried little more than a pilot's eyes and a radio. It fielded the AH-1 Cobra for attack, a Vietnam-era gunship whose airframe dated back to 1965. It fielded variants of the UH-1 Huey for utility work, a design old enough that many of the pilots flying it had fathers who had flown its earliest models. 3 separate aircraft families, 3 separate maintenance pipelines, 3 separate training programs, and none of them built with the Soviet air defense environment of the 1980s in mind. The math was blunt. The Army was operating roughly 9,000 helicopters across its active fleet, a significant fraction of them scout and light attack types approaching or exceeding 20 years in service. Replacing them piecemeal, one aging airframe at a time, would cost more over the following 2 decades than replacing them once, correctly with a single modern design built around a shared engine, a shared avionics architecture, and for the first time, genuine low observable characteristics. The LHX study proposed exactly that. One family of aircraft in two variants that could scout and attack, not a helicopter added to the fleet. A helicopter meant to make most of the existing fleet obsolete. Word of a potential contract that size moved through the aerospace industry immediately. This was not a niche military purchase. Early Army estimates floated a production run in the thousands of airframes, a number large enough to sustain an entire company's helicopter division for a generation. Four of America's most capable rotorcraft manufacturers moved to compete for it. Bell Helicopter, with decades of light helicopter experience going back to the OH-58 itself. Boeing Helicopters, fresh off building the CH-47 Chinook and developing deep expertise in composite airframes. McDonnell Douglas, builder of the Apache, bringing combat attack pedigree. Few competitors could match. And Sikorsky Aircraft, the company that had defined American helicopter design since the 1940s, now pursuing something it had never built before, an aircraft engineered from its first sketch to be difficult for radar to find. Through the mid-1980s, these companies studied, proposed, and in some cases formally teamed, each betting engineering hours and internal funding on a requirement that did not yet have a signed contract behind it. The Army, for its part, kept refining what it was actually asking for. By 1988, the requirement had crystallized around a demand no American helicopter had ever fully met. An aircraft with a radar cross-section reduced by more than an order of magnitude compared to conventional rotorcraft, combined with reduced infrared and acoustic signatures, all while retaining the speed, agility, and weapons capacity the Army needed for both scouting and direct attack. No single company could easily absorb the technical and financial risk of that combination alone. Stealth aircraft design, at that point, remained the domain of a handful of specialized programs, the F-117, still classified when LHX began, the B-2, years from its first flight. Applying that discipline to a helicopter, a machine defined by an exposed, spinning rotor system that resisted every conventional stealth-shaping technique used on fixed-wing aircraft, was an unsolved problem in 1988. By the time the Army was ready to select a winner, it would not choose a single company. It would choose a partnership. Two of the industry's largest rotorcraft builders, combining what neither could deliver alone, for a contract that would define both companies' helicopter divisions for the next 2 decades. In April 1991, the Army made its decision. The contract went not to Bell, not to McDonnell Douglas alone, but to a team that had formed specifically to answer LHX's hardest problem: Boeing Helicopters and Sikorsky Aircraft, bidding together under the name The First Team. The logic behind the pairing was straightforward, even if the engineering behind it was not. Sikorsky brought 7 decades of rotor and airframe design experience, along with the aerodynamic groundwork already underway to shape a helicopter body that could deflect radar energy instead of reflecting it back to its source. Boeing brought something Sikorsky's design alone could not deliver at the scale LHX required: deep experience in composite manufacturing and, critically, the avionics and mission systems integration. The aircraft would need to function as both a scout and a shooter on a single airframe. Neither company had built a genuinely low observable helicopter before. Between the two of them, they believed they could. The contract, worth $2.8 billion, called for 6 flying prototypes to prove the concept before any production decision was made, later reduced to 2 as the program's early cost pressures began to show. That same month, the aircraft received the name it would carry for the next 13 years: RAH-66 Comanche. Reconnaissance and Attack Helicopter, 66, a Native American tribal name, continuing an Army naming tradition that had already given the service the Apache, the Kiowa, and the Black Hawk. Assembly of the first prototype began in November 1993, split across 2 facilities 400 miles apart, the airframe taking shape at Sikorsky's plant in Stratford, Connecticut, while Boeing's Philadelphia facility built major subassemblies and the mission systems architecture that would eventually be shipped north for final integration. It was, in practical terms, 2 separate aerospace companies building one aircraft from opposite ends of the same production line, coordinating a level of engineering complexity neither had faced on a helicopter program before. This was the point of no return. Two publicly traded aerospace giants had now committed engineering divisions, manufacturing capacity, and corporate reputation to a single airframe that did not yet exist in metal. The requirement that had started as a 1982 Army study survived 9 years of competitive proposals and outlasted 3 other corporate bidders, now had a contract number, a factory floor, and a deadline. What remained unproven was whether the central promise of the entire program, a helicopter an enemy radar operator would struggle to see at all, could actually be built. That question would not be answered on paper. It would be answered on a runway in Connecticut, in front of a stopwatch, in January 1996. The aircraft that emerged from those two factories in 1995 looked unlike anything the U.S. Army had ever flown. Where every previous American helicopter had a rounded, riveted, unmistakably mechanical silhouette, the Comanche had a faceted fuselage, flat-angled panels meeting at hard edges instead of smooth curves, the same shaping principle that gave the F-117 Nighthawk its jagged, almost crystalline profile. Radar energy striking a rounded surface bounces back toward its source in a wide, easy-to-detect return. Radar energy striking a flat-angled panel scatters away in a direction the receiving radar never sees. The Comanche's entire outer skin was built around that single physical principle, panel by panel. The weapons themselves disappeared into the design. Every previous American attack helicopter, including the Apache, carried its missiles and rockets on external pylons, stub wings jutting from the fuselage, each one a flat metal surface that reflected radar energy and added to the aircraft's detectable size. The Comanche buried its primary weapons load inside an internal bay in the lower fuselage, doors closing flush against the skin the moment the missiles were away. For the first time on an American helicopter, going stealthy and going armed were no longer opposing design choices. The landing gear retracted fully into the fuselage after takeoff, eliminating another set of exposed metal surfaces that would otherwise catch and return a radar pulse. The engines were fitted with infrared suppression systems, mixing cool bypass air into the exhaust stream before it left the aircraft, cutting the heat signature a heat-seeking missile would need to lock onto. And above the rotor mast sat the aircraft's most distinctive planned feature, a millimeter-wave longbow fire control radar, the same targeting technology fitted to the Apache, but shrunk and mounted so the Comanche could hover behind a tree line and scan for targets with only the disc-shaped radome exposed above the foliage, the rest of the aircraft, and the crew inside it, hidden from view entirely. Even the rotor itself was redesigned around the acoustic half of the stealth equation. A 5-bladed, bearingless main rotor turned more slowly than conventional rotor systems, each blade doing less work individually, which meant a quieter blade tip speed and a lower-pitched rotor sound less likely to carry across open terrain. Engineers had studied years of acoustic data, showing that a distinctive, high-pitched rotor chop was often what gave a helicopter's position away long before it came into visual range. Every element of the aircraft, from the shape of its skin to the pitch of its rotor blades, had been built around a single unifying purpose. An enemy on the ground should not know the Comanche was there until it chose to be seen. On the 25th of May, 1995, the first prototype, tail number 94-0327, rolled out of Sikorsky's Stratford plant in front of Army officials, company executives, and a press corps that had waited years to see whether the promises on paper matched the aircraft in metal. It did not fly that day. Ground testing, taxi trials, and systems checks would occupy the months that followed, each one another data point the program needed before risking the aircraft in the air. The first flight came on the 4th of January, 1996. Prototype 94-0327 lifted off from Sikorsky's Development Flight Center, climbed to altitude, and flew for the first time 30 minutes in the air, well within the conservative envelope test pilots always fly on an unproven design. It was not a dramatic flight. There were no maneuvers to impress a crowd, no low pass down a runway. It was by design uneventful, which was, for a stealth aircraft on its very first sortie, exactly the outcome the engineers wanted. What that 30-minute flight proved was simple and enormous at the same time. An aircraft built from the ground up around radar-evading geometry, an internal weapons bay, and a suppressed acoustic and infrared signature could actually leave the ground and fly like a helicopter. 14 years after the LHX study, First asked whether such a machine was possible, the Army finally had a partial answer. It could be built, it could fly. Whether it could survive contact with the one force no engineering team had accounted for, the federal budget, was a different question entirely, and the years ahead were about to answer it. By the time the Comanche was flying test sorties in the late 1990s, a different kind of scrutiny had already caught up with it, not from an enemy radar operator, but from the U.S. Government Accountability Office. Between 1996 and 1999, the GAO issued a string of reports on the program, and their language, stripped of bureaucratic softening, amounted to the same warning repeated in different words each year. The Comanche's cost per aircraft was rising faster than its capability was being proven. The math behind that warning was hard to argue with. When LHX began in the early 1980s, Army planners had discussed a production run in the thousands, enough airframes to replace nearly the entire Scout and light attack fleet at once. By 1996, that number had fallen to roughly 1,200 aircraft. By the end of the decade, internal Army planning figures had cut it again, to a program of record hovering around 650. Each reduction meant the same fixed research and development costs. The billions already spent on radar-defeating geometry, internal weapons integration, and a purpose-built engine were being divided across fewer and fewer airframes, driving the effective cost of each individual Comanche higher with every revision. The establishment's objection was not irrational, and it deserves to be understood on its own terms rather than dismissed as short-sighted bean counting. Congressional appropriators and Pentagon budget officials were not questioning whether stealth technology worked. They were asking a narrower, harder question. Could the Army justify spending on a single-purpose scout and attack helicopter at a per-unit cost climbing toward tens of millions of dollars when the aircraft it was meant to replace, the aging OH-58 Kiowa, could still fly, and unmanned alternatives were emerging that promised similar reconnaissance value at a fraction of the cost and none of the risk to a pilot's life? It was a coherent, fiscally grounded position, built on real numbers rather than institutional inertia. The program's own internal history gave critics further ammunition. Between 1988 and 2000, the Comanche underwent multiple formal restructurings, schedule resets, requirement adjustments, funding profile changes, each one an admission that the previous plan had not held. Milestones set in the early 1990s slipped by years, not months. A program originally expected to reach production by the mid-1990s was, by the turn of the millennium, still in prototype testing, its engineering and manufacturing development phase not even beginning until June of 2000, 9 years after the initial contract award, and 18 years after the LHX study that started it all. And yet, set against every one of those objections, the engineering data coming back from the two prototypes told a different story. Radar cross-section testing, conducted against instrumented ranges designed to measure exactly how visible an aircraft appeared to different radar bands, confirmed what the design team had promised on paper back in 1991. The Comanche's radar signature measured dramatically smaller than that of a conventional helicopter of comparable size, by most public estimates roughly 2 orders of magnitude below the Apache's return. Acoustic testing showed the slower-turning 5-blade rotor produced a measurably lower and less distinctive sound signature at operational ranges. And flight testing, cautious and incremental as it was, kept validating basic airworthiness with no fundamental aerodynamic flaw discovered in either prototype. The Comanche, in other words, was not failing to become what it was promised to be. It was becoming exactly that, more slowly, and at a steeper cost per airframe than anyone in 1991 had been willing to admit was likely. The people signing off on ever larger budget lines to keep the program moving did not yet know whether the aircraft they were fighting to save would ever fly a single operational mission. They only knew, with each passing year, that it was becoming more expensive to find out. On June 1, 2000, the Comanche program crossed into its most consequential phase, engineering and manufacturing development, the stage where a prototype design becomes a program committed to actual production. The contract for this phase alone was worth $3.1 billion, on top of the $2.8 billion already spent getting 2 prototypes into the air. The Army was no longer testing whether the Comanche could fly. It was now formally preparing to build it in numbers. The production numbers behind that commitment tell their own story of a program under mounting pressure, revised almost annually. When LHX was first conceived in the early 1980s, planners discussed replacing the Army's Scout and Light Attack fleet nearly one for one, a number that would have run into the thousands. By 1996, the program of record had settled at roughly 1,230 airframes. By 2002, that figure had been cut again, down to 650 aircraft, and in the program's final planning documents before cancellation, the number had fallen further still, to 227 aircraft, with only 121 funded for delivery through 2011. Three numbers, three different decades of the same program, each one smaller than the last. A helicopter conceived to replace an entire fleet had by its final years shrunk into a specialized platform the Army could barely afford in triple digits. The engineering itself, meanwhile, kept clearing hurdles that had defeated every previous attempt at a stealth helicopter. The T-800 engine, developed jointly by Honeywell and Rolls-Royce specifically for this airframe, delivered roughly 1,560 shaft horsepower per engine, sufficient power for the aircraft's mission profile while running smaller and lighter than engines used on comparable conventional helicopters, a direct product of the weight discipline the stealth design demanded everywhere else on the aircraft. The longbow radar system, already proven on the Apache, was successfully miniaturized and integrated into the Comanche's mast-mounted radome, validating that the aircraft's central sensor concept, scanned from behind cover, expose almost nothing to enemy detection, was not just a design sketch but a working system. And the price tag for turning that working system into a fielded fleet kept climbing into numbers few programs in Army aviation history had ever approached. Independent estimates for full-rate production, factoring the entire remaining development and manufacturing run through completion, placed the total lifetime cost of the Comanche program as high as $39 billion, a figure that, once it began circulating in Pentagon budget discussions and congressional hearings in the early 2000s, did more to define the program's public reputation than any single technical achievement had. By the early 2000s, the Comanche stood as something genuinely unusual in American military aviation, a program that had spent over a decade proving its central engineering premise: correct radar test range by radar test range, flight hour by flight hour, while simultaneously watching the fleet it was meant to build shrink by more than 80% from its original ambition, and its projected total cost climbed toward a figure that rivaled entire other weapons programs. The aircraft worked. The math around it increasingly did not, and that math was about to collide with something no engineering report could account for: a war the Comanche had never been designed to fight. On September 11, 2001, the strategic assumptions that had shaped the Comanche for nearly 2 decades stopped applying overnight. Every year of the program's development, from the LHX study in 1982 through the contract award in 1991 to the first flight in 1996, had been built around a single scenario: a large-scale conventional war against a heavily armed, radar-dense opponent, most likely across the plains of Central Europe. The Comanche existed to survive that specific battlefield, the one defined by ZSU-23 4-gun systems and SA-9 missile batteries moving alongside Soviet tank columns. That battlefield had already been fading since the Soviet Union's collapse a decade earlier. After September 2001, it disappeared from Army planning almost entirely, replaced within months by a different war. The service had not built its aviation modernization plan around it all. By 2003, the United States Army found itself fighting in Afghanistan and Iraq simultaneously. Conflicts defined not by dense conventional air defenses, but by insurgency, urban combat, and a desperate immediate need for helicopters that could move troops, resupply outposts, and provide overwatch in large numbers right now. The kind of threat a Comanche was built to defeat, a sophisticated radar-guided air defense network, was almost entirely absent from either battlefield. The threats that were present, rocket-propelled grenades, small arms fire, shoulder-fired heat-seeking missiles fired at close range, were exactly the threats where stealth shaping offered the least advantage because they didn't rely on radar detection at range in the first place. Inside the Pentagon, this mismatch did not go unnoticed. General Peter Schoomaker, who became Army Chief of Staff in August 2003, brought with him a broader reassessment of how the service should modernize, built around a concept the Army was calling the objective force, a push toward lighter, more deployable, more networked formations, with growing emphasis on unmanned systems that could deliver reconnaissance value without risking a pilot's life at all. Under that lens, a single-purpose, extraordinarily expensive, manned stealth scout helicopter, one that had already consumed over a decade of schedule and was still years from fielding in meaningful numbers, looked less like the future of Army aviation and more like a very expensive answer to a question the Army was no longer being asked. The Army launched a formal 6-month internal study in 2003, tasked with a blunt question: given current and foreseeable threats, and given the Army's actual budget constraints, did the Comanche program still make sense? The study's conclusion, delivered in early 2004, was direct. Comanche's stealth advantage, so carefully engineered against a Cold War-era radar threat, provided limited value against the anti-aircraft threats the Army was actually facing in the field. Man-portable missiles and small arms that a radar-evading fuselage did nothing to defeat. Meanwhile, the Army's existing helicopter fleet, the Blackhawks, the Apaches, the aging Kiowa Warriors still flying daily missions over Iraq, was wearing out under real combat operational tempo, far faster than any peacetime maintenance schedule had anticipated, and needed money for upgrades and replacement parts immediately, not years from now. The demand that emerged from that study was not aimed at a person. There was no rival executive maneuvering for personal advantage, no bureaucrat settling an old score. The demand came from an institution recalculating, in real time, what $1 spent on a stealth helicopter program actually bought compared to $1 spent on an unmanned aircraft or a fleet already flying missions in a war zone. 21 years of engineering, 2 working prototypes, and $6.9 billion in sunk cost sat on one side of that calculation. On the other side sat a war already being fought right now with helicopters that badly needed money the Army did not have. The recommendation reached the desk of the Acting Secretary of the Army in early February 2004. The decision it called for was not a modification, a delay, or another restructuring. The program had already absorbed years of those. It called for cancellation in full. On February 23, 2004, Acting Secretary of the Army, Les Brownlee, and Army Chief of Staff General Peter Schoomaker walked into a Pentagon press room together. They did not soften the announcement. The RAH-66 Comanche program was over. 21 years of development, $6.9 billion spent, 2 flying prototypes built, 0 aircraft delivered to a single combat unit. It's a big decision, Schoomaker told the reporters in the room, but we know it's the right decision. The official story was restraint, not defeat. Army leadership framed the cancellation as fiscal discipline, a hard, mature choice to redirect resources toward a force actually at war, rather than a program still years from the battlefield. Nothing in the announcement blamed the engineering. Nothing questioned whether the stealth technology worked. The real story sat underneath that framing, in numbers few reporters in the room fully grasped that day. Contract termination alone would cost the government an estimated $450 to $680 million, paid out to Sikorsky and Boeing simply to close down a program neither company had failed to deliver on. The aircraft itself was not being fixed, delayed, or restructured one more time. It was being closed. 2 prototypes remained. Tail numbers 94 to 0327 and 95001. Between them, a few hundred flight hours. Not one combat sortie. Not one operational deployment. Built to disappear from radar, they had instead simply disappeared from the program roster. No factory fire, no structural failure, no single point of blame. Just a signature on a Pentagon memo, and 21 years of work stopped in a single afternoon. The money did not disappear along with the aircraft. It moved. At the same February 2004 press conference where they announced the Comanche's cancellation, Brownlee and Schoomaker laid out where the $14.6 billion originally earmarked for Comanche production between 2004 and 2011 would go instead. The plan had 3 parts, and all 3 were built around the same underlying logic. Buy more of what already worked, right now, rather than wait years for a single specialized aircraft to arrive. The first and largest piece went toward the Army's existing utility fleet. Roughly 796 additional UH-60 Blackhawk helicopters were funded for purchase, a proven, mass-produced airframe already flying daily missions over Iraq and Afghanistan, available from the production line in a fraction of the time a new stealth design would require. The second piece funded modernization rather than new production. Upgrades across approximately 1,400 helicopters already in the Army's active inventory, extending the service life of Blackhawks, Apaches, and Chinooks. That combat operational tempo was wearing out faster than any peacetime maintenance plan had anticipated. The third piece pointed toward the future the Army now believed it actually needed. Funding was redirected to accelerate development of unmanned aerial vehicles, platforms like the RQ-7 Shadow and the smaller hand-launched Raven, systems that could deliver exactly the kind of low-risk reconnaissance value the Comanche had once promised, without a pilot's life riding on the outcome, and without 2 decades of development time standing between the requirement and the field. An Army study conducted alongside the cancellation decision identified a need for roughly 368 new armed scout helicopters going forward, a gap the service still had to fill, just not with the aircraft it had spent 21 years building. That gap did not stay open for long, and it did not close cleanly either. The Army moved quickly to select a replacement for the aging OH-58 Kiowa Warrior, the Bell ARH-70 Arapaho, built deliberately as the opposite of everything the Comanche had been, an off-the-shelf commercial airframe based on the existing Bell 407, promising a fast, cheap path to a modern scout helicopter without a single new stealth technology to develop from scratch. It seemed on paper like the lesson of Comanche fully absorbed. 4 years later, in October 2008, the ARH-70 was canceled too, undone by the same disease in a different form, cost overruns that outpaced the budget built to contain them. Nowhere in any of this, the Blackhawk purchases, the fleet upgrades, the UAV acceleration, the failed Arapaho replacement, did the Comanche's own engineering play any role. The aircraft's radar-defeating fuselage shape, its internal weapons bay, its suppressed rotor acoustics, none of it was salvaged, adapted, or carried forwards into what came next. The 2 prototypes that had proven those systems worked were retired to a museum before either the Blackhawk purchases or the UAV programs they funded had even begun ramping up. The money that had built the Comanche's stealth breakthrough was now buying more of exactly the kind of helicopter the Comanche had been designed to replace. 15 years after the Comanche died, the Army tried again. In 2019, the service launched the Future Attack Reconnaissance Aircraft Program, FARA, built around a mission profile that would have sounded immediately familiar to any engineer who had worked on Comanche, a fast, survivable, next-generation scout and light attack aircraft, designed to operate ahead of ground forces and fill precisely the reconnaissance gap the Army had been trying to close since it canceled the Kiowa Warrior's last unsuccessful replacement back in 2008. 2 competing prototypes moved into development from Bell and from Sikorsky, the same company, now under Lockheed Martin ownership, that had helped build the Comanche's stealth fuselage 2 decades earlier. In February 2024, almost exactly 20 years to the month after Brownlee and Schoonmaker stood at that Pentagon podium, the Army canceled FARA 2. The stated reason was different in its details, but identical in its shape. The battlefield had changed again, this time driven by lessons from Ukraine, where cheap, mass-produced drones were proving that low-altitude reconnaissance no longer required a manned aircraft at all, stealth or otherwise. The same institution facing the same underlying question, does this expensive, specialized, manned aircraft still match the war we're actually fighting, arrived at the same answer twice, 20 years apart. That is the honest verdict on the Comanche, and it complicates the easy version of this story. The program was not a case of bad engineering finally catching up with an over-ambitious design. Every technical promise made in 1991 was, by the time of cancellation, a promise the aircraft had kept. The radar cross-section worked. The internal weapons bay worked. The acoustic signature reduction worked. What failed was not the machine. What failed was the 21-year gap between the threat the Comanche was designed to defeat and the threat the Army actually needed to fight by the time the aircraft was finally ready. A gap so wide that an entirely different war had started and reshaped the battlefield before the first production airframe could ever reach a unit. Boeing and Sikorsky, the 2 companies that built it, absorbed the program's end and moved on largely intact. Sikorsky continued developing rotorcraft technology that would eventually surface in later designs. High-speed compound helicopters, unmanned rotorcraft concepts, some of it informed by lessons learned, building a stealth airframe that no other company in America had ever attempted. Boeing's helicopter division continued building Chinooks and Apaches, the conventional aircraft the Comanche was originally supposed to help replace. Neither company's helicopter business depended on Comanche's survival, and neither one's ended when it didn't survive. What remains of the program sits today at the United States Army Aviation Museum in Fort Rucker, Alabama. Two airframes, 94-0327 and 95-01, the only Comanches ever built, standing complete, painted, and permanently grounded, having flown a combined total of a few hundred hours between them across nearly a decade of testing. Visitors walk past them the way they walk past every other retired aircraft in the collection, reading a placard, moving on to the next exhibit. Few of them know that what they are looking at once represented the most advanced stealth helicopter technology the United States had ever built, and that the technology itself was never proven wrong. Only late. 21 years to build it. 20 years to try to build it again. Neither attempt ever fired a shot in anger. The war it was built for never came. The war that came never needed it.